This is a bench-mounted universal testing machine. It can test specimens both in extension by pulling them apart or in compression by crushing them. The universal testing machine design is based on the Hounsfield design. Hounsfield were the first manufacturers of such machines, and it was a British company. Not much has changed from the original design, from a crank-operated machine to where it is now automated with some software attached to it, in this case called Bluehill. Bluehill is the standard software with this machine manufacturer Instron. Universal testing machines are often referred to as Instrons as a shorthand. The reason being is that Instron is the world-leading manufacturer of such machines, and most likely, whether in industry or academia, this is the most commonly found brand of universal testing machine across the globe. The software attached to the machine via the monitor is the latest version of Bluehill, called Bluehill Universal. It is operated via the touchscreen monitor, which has a 4mm thick screen, so that it can be used within industrial settings. Consequently, when inputting parameters into the software, a firm push on the screen is required. On the front of this machine is a safety screen, which is attached via a magnet. So to open it, simply pull on the handle, no latches or locks are required, and then this grants access to the testing area. Here we have two fixing points. This is fixed and stationary. The second point is attached to a load cell. This load cell is interchangeable. Currently, there is a 30 kN load cell fitted into the machine. If materials being tested require larger or smaller forces to be applied, the load cell can be taken out and another load cell inserted. The load cell is attached to a crosshead. The crosshead is attached to the machine through this frame via pulleys, cogs, and lead screws. It is the crosshead which moves up and down. The base fixing here is stationary and does not move. On the side of the frame here is a stop, which is controlled by simply turning the screw, and that can slide up and down. This is a safety feature to prevent the crosshead crashing into the base plate and then stopping the machine and potentially ruining tens of thousands of pounds of equipment. The placement of the stop in the correct location is very important. This large red button is the emergency stop on the machine. If anything becomes tangled or the machine needs to be suddenly stopped in an emergency, depress this button and the machine will shut down. It also shuts down the software and will take several minutes to boot everything back up, but it is there for your safety and others. Next to the emergency stop is a black rocker switch, also referred to as the jog button. This rocker switch moves the crosshead manually. To press it at the top, the crosshead moves up, and press it downwards and the crosshead moves down. To input the correct data into the software, from the home screen, zero the force of the load cell by tapping on balance load at the bottom of the screen. Zero the position of the crosshead by tapping on zero displacement. Then tap along on before test and enter the relevant parameters before starting the test. In specimen label, type in the name of the thermoplastic polymer. Select the keypad from the bottom of the screen. This specimen is unmodified polystyrene. The keyboard has predictive text, and this can be utilized. Under the label polymer type, use the drop-down option to select the common abbreviation used for the specific polymer. In this case, it is PS. Then input the width and thickness of the smallest cross-sectional area location. In this case, for the polystyrene, it is 9.86 millimeters for width, and for thickness, it is 4.04 4 mm. The length is the 18 mm discussed earlier and will not change for any of the specimens to be tested. For polystyrene, the rate of extension is 4 mm per minute, and in this case that doesn't need to be changed on screen. Once all the relevant parameters have been entered, the specimen can be fixed into the instron. Because the specimen is in a flat shape, grips will be used to hold it in place. When using grips, place the specimen between the two, ensure it touches the sides, which makes sure it remains vertical, and check there is the same amount of material in each grip. With one hand, hold the specimen in place, and with the other, tighten the lower grip first. Then the upper grip is tightened in the opposite direction. Always start with tightening the lower grip first, as the upper grip, which is connected to the load cell, can twist, resulting in damaging the expensive load cell. It's also important for when the specimen is gripped that the grips do not hold the specimen beyond the shoulder area going into the gauge length area. Otherwise, false results will be obtained. Close the magnetic front safety screen before beginning the test. This is to ensure safety against projectiles from fractured specimens. The machine will run with the door open. However, where possible, always close the screen.